Hello, welcome once again, students. Let's take one more problem. We have to evaluate integral 5x plus 2 divided by 3x minus 4. So I assume this as I, and here I have dx. I have to evaluate this. What does it mean? It means I need to integrate the given function. See, what I do here is I will take, okay, first of all, let me write that this problem is a particular type of problem. It's a type. What is this type? This type is we have linear in numerator, linear upon linear, linear upon linear. This is linear expression, linear algebraic expression in numerator. You can say why I'm calling this linear, because it's in the form ax plus b and denominator is in the form cx plus d. Ax plus b upon cx plus d dx. So this is linear algebraic in x upon linear. Now, so what's the method here? How do I solve this? For this, what I will do is I will take 5 common from numerator. Take 5 common from numerator. That is, I will get x plus 2 upon 5. And denominator is 3x minus 4, no change. Then this 5 is written outside because this is a constant. The numerator I have x plus 2 upon 5. But here what I do is I divide by 3. I divide by 3 so that I can multiply 3 here. So I multiply 3 and now what I get is 3 times x plus 2 upon 5, 3x minus 4. Why I am doing so, you will understand in a while. So next step is 5 upon 3. This becomes 3x plus 6 upon 5. This becomes 3x plus 6 upon 5 upon 3x minus 4. So the reason for I dividing by 3 and multiplying 3 is I want to have the coefficient of x in numerator same as the coefficient of x in denominator. The coefficient of x in denominator is 3, so I made the same in numerator. Now what I do is, therefore I equals to 5 over 3. Then look at the denominator. The denominator is 3x minus 4. And numerator I have 3x plus 6 over 5. I will write 3x minus 4 plus 4. What I did, I subtracted 4 so I had to add 4. If you subtract 4, you add 4. Okay, you make a change, you make a counter change, or else it will be wrong. So plus 6 over 5, and here you have 3x minus 4 dx. And why did I do this? Because I wanted to have the same expression in numerator what I had in the denominator. In denominator, I had 3x minus 4, so I made sure that I have the same in numerator. So numerator, I got it. What further I'll do? I will simplify this. So the next step I will get here is 5 over 3 and 3x minus 4 upon 3x minus 4 I split the denominator. Once I see exactly what I have in the denominator, I split it. So 3x minus 4 upon 3x minus 4 plus, here I get 20 plus 6, 26 upon 5 upon 3x minus 4 and dx. This gets cancelled. So I get 5 over 3. This is 1 here. And here I get 26 upon 5 into 1 upon 3x minus 4 dx. This will go down, or you could have simply written, or this I can simply write as 26 upon 5 times 3x minus 4. So the next step is this 5 will go down. Now next step, I write separate integration. So here I get I equals to 5 over 3 integral 1 dx plus 5 over 3 5 over 3 integral 1 dx See students, what I'm doing is I am multiplying this 5 over 3 inside and also distributing the integral. So because this 5 over 3 is outside the bracket, so it will get multiplied to both. It will multiply to 1. It will also multiply to this. Okay, so I have 5 over 3 1 dx plus I have 5 over 3 integral 26 upon 5 times 3x minus 4 dx. Okay. So next step, this 26 upon 5 is a constant. It will come out. So I will get I equals to 5 over 3 1 dx plus 26 over 3, 5 gets cancelled. 26 over 3, 1 upon integral 1 upon 3x minus 4 dx. So I get I equals to 5 over 3 integral 1 dx is x plus 26 over 3, and here see what I have. See students what I have. I have 1 upon 3x minus 4. I want to write integration of 1 upon 3x minus 4. So what function is this? It is reciprocal function. Tell me what is integration of 1 upon x dx? Log of mod x plus c. Integration 1 upon x dx, log mod x plus c. Here what you notice that this function, here is same as this function. Only thing that we have done is, in place of x, we are writing 3x minus 4, which is in the form ax plus b. This b is negative 4. So whenever in a basic definition result, you have x being replaced by linear algebraic of x, the result can still be applied. So integral 1 upon 3x minus 4, I can still integrate, and it will be log of 3x minus 4. See, what was 1 upon x? Log mod x. So 1 upon 3x minus 4, log mod 3x minus 4, the whole upon 3. Why divide by 3? Because the coefficient of x is 3. The stage where you are applying the result, if you notice that coefficient of x is some number other than 1, you need to divide by that. So I divided by 3. plus C, and this will be your final answer. This 3 and 3 will multiply, you will get 26 by 9. This is your final answer. I hope you all have understood this. So students, now we are going to begin with integration by method of substitution. Before I begin with this, I must tell you all that this particular part that we have, integration by method of substitution, it is the major part of integration. It is the major part of integration. If you understand this part, then you will find that 90% of problems that you come across in integration will become easier for you. So it is very important that we understand this part, integration by method of substitution. Now, when I teach you this part, there will be a theorem to be done here. Okay, we will have a theorem in this. Now, this theorem is known as theorem of method of substitution. So, theorem of method of substitution, or you can say theorem of integration by method of substitution. This is the main theorem. I have put so many stars because this is very important part of integration. So in order to understand the whole topic of indefinite integration, it is very important for a student to get a good hold on this particular theorem and the idea behind this theorem. Now here one more thing I would like to say, that with this theorem there are 3 sub-theorems. Like in a topic, as you have subtopics. So this is main theorem. Theorem of method of integration is the main theorem, and inside this I have 3 sub-theorems. So those are known as the corollaries. Corollary 1, corollary 2, and corollary 3. So these all three are basically originating from this main theorem. These all 3 corollaries are originating from this theorem. So when we will have proved the first theorem, that is theorem of method of substitution, after proving this theorem, we will have to write 1 or 2 extra steps to prove these theorems. Remember, these corollaries, which are sub-theorems, they are all originating from the main theorem. What is main theorem? The theorem of integration by method of substitution. So you can say that these 3 are children of this. They are the children of this. Or you can say this is the parent body. This one is the parent body, and this is the children of this main theorem. But it is found that many problems in integration can be solved using these corollaries independently. You can solve many problems of integration by using these corollaries only. That is, you will not have to go to the main theorem. Using these only you can solve the problems. You will not have to go to method of substitution. So what we will do, a particular integration problem, when I notice that I can solve by using corollary 1, I will solve it using this only. I will not go for the bigger theory. Nevertheless, all the problems that you are solving using corollaries, all these integration problems which you are solving using corollaries, these all problems can always be solved using main theorem. But what we will prefer to solve them by corollaries. Okay, so what I do now here is, in order to make the subject easier and conducive, I will first write all the corollaries. I will explain you the corollaries. See, we are not going from top to bottom. What I am taking is, I am taking the reverse path. Okay, in order to make it more easy for you. So what I will do is, let me first teach you all the corollaries. I will make you understand the corollaries. Then in some lecture, I shall prove this method of substitution theorem, and then I will relate these corollaries with this, and you will find that everything you have understood. It is very convenient for me to do it this way. I do not deny that I should actually be going in order this way. But what will happen? The topic will become too theoretical, and in that case, the main motive that we have, the main motive is to solve the problems faster. That motive will be lost. Okay, so in order to make the things look very easy, we will go by the corollaries first. So here I write integration by method of substitution. I write here, this theorem has three very important sub-theorems. Number one. See, what is number one? The number one says integration of f dash x upon f of x dx equals to log of mod f of x plus c. This is number one. Okay, so understand this. What does this theorem say? It states that if you have an integrand, it states that when you have an integrand where you notice that numerator of the integrand, you can check, numerator of the integrand is derivative of denominator. What do you have? You have f dash x upon f of x. If the numerator of the integrand is derivative of denominator, then the integration of this whole integrand will be log of mod of denominator. So let me give you an example for this. For example, suppose I have to integrate one function which is 2x minus 9 upon x square minus 9x plus 7. So this one you want to integrate. What do you notice? You notice that the denominator here is x square minus 9x plus 7. If I differentiate this with respect to x, I get d by dx of x square, which is 2x, minus, I get d by dx of 9x, which is 9 into 1, that is 9, plus d by dx of 7, which is 0. So the denominator derivative is 2x minus 9. So here I notice that derivative of denominator is present in numerator. So the whole answer will be log of mod of denominator x square minus 7x, x square minus 9x plus 7 plus c. That's it. This is corollary number 1. The second corollary is integral f of x, integral f dash x upon square root of f of x dx. What I notice here, I notice that in the integrand, what is meaning of integrand? The function that you want to integrate. You are integrating f dash x upon root f of x. So this is, numerator is f dash x, which is derivative of f of x, and the denominator is square root of f of x. So if you notice something like this, you will write the answer as 2 root f of x plus c. What you will write? You will write 2 root f of x plus c. Remember students, here you had numerator f dash x, but the denominator was not root f of x. Denominator was not root f of x. Here you have denominator as root f of x. So f dash x upon root f of x dx is 2 root f of x plus c. I write example for this. Suppose I have here cos of x upon root of sin x. So what do you notice? We notice the denominator is square root of sin x. The content of the root is sin x. Inside the root you got sin x, and the numerator is derivative of sin x. So its integration will be 2 root sin x plus c. Cos x upon root sin x is 2 root sin x plus c, because cos x is derivative of sin x, which is inside the square root in the denominator. Remember, it has to be exactly in this form. You are not allowed to have anything other than this. No, if it is exactly in this form, then only you can use the result. Then we have the third one. The third corollary is integral f of x raised to n. F of x is some function of x. F of x raised to n into f dash x dx. So what is integrand here? This part is the integrand. The integrand is this part. If you have an integrand like this, where you have a function having power n, and derivative of that function is multiplied with this, then the answer that you write for this is, you write answer for this as f of x raised to n plus 1 divided by n plus 1 plus c. What is the answer for this, students? It is f of x raised to n plus 1. You increase the power of f of x by 1 and you write as the new power, and you also divide by n plus 1. So I give you an example for this. The example would be, for example, suppose I have log x raised to 3 into 1 upon x dx. You can check what are you integrating. You are integrating this function log x the whole cube into 1 upon x. So this becomes your f of x. This becomes your f of x, and this is f dash x. See, inside the bracket you have log x, which is f of x, and here you have d by dx of log x is 1 upon x, f dash x. So it's in the form f of x raised to 3 into f dash x dx. What will be the answer? The answer is log x raised to 3 plus 1, that is 4 upon 4 plus c. I will take one more example for this. Let me take one more example for this. Integral sine raised to 7x into cos x dx. So the next step I will write this as, I know sine raised to 7x is sine x the whole raised to 7 into cos x dx. So this is f of x raised to n. You can check f of x raised to n into f dash x dx. In the integrand, you notice that integrand is in this form. So the answer here will be sin x raised to 7 plus 8, 7 plus 1, that is 8, upon 7 plus 1, that is 8 plus c. This is final answer. I hope you all must have understood. Let us write all these three corollaries once again. So the first one was integral f dash x upon f of x dx equals to log of mod of f of x plus c. The second one was integral f dash x over square root of f of x dx is equal to 2 root f of x plus c. And the third one was f of x raised to n multiplied with f dash x dx is equal to f of x raised to n plus 1 upon n plus 1 plus c. So what we will do now is, using these three corollaries, we shall take the discussion on indefinite integration ahead. So I want you all to recall the results that we had done earlier. So students, in the list of the results, if you remember, if we speak about the integration of trigonometric functions, then I had integration of sin x, I had integration of cos x, I had integration of sec x tan x, I have integration of cosec x into cot x, integration of sec square x, and integration of cosec square x. See, these are 6 integrals that I have. Sin x dx, cos x dx, sec x tan x dx, cosec x cot x dx, sec square x dx, and cosec square x dx. I have integration of these 6 functions. But you need to understand that for some reason we do not have integration of tan x. I do not have integration of tan x. I do not have integration of cot x. I do not have integration of sec x and cosec x. So from the 6 standard functions, from the 6 standard trigonometric functions, we had integration of only these 2. And the remaining 4 are yet to be integrated. Now, if you want to know the reason that we could not integrate these, the reason is very simple, that we obtained the integration of these functions. We obtained the integration of these functions using the definition. And if you remember, the definition was based on derivative. I could write d by dx of sin x, which was equal to cos x, and hence I got integration of cos x dx as sin x plus c. So I had integration of cos x. I could write integration of cos x because I knew that cos x is derivative of sin x. I knew that cos x is derivative of sin x. Same way, I could write integration of sec square x. I could write integration of sec square x because I know that sec square x is derivative of tan x. D by dx of tan x is sec square x. So by definition you write, this implies derivative of tan x is sec square x. So integration of sec square x dx is equal to tan x plus c. So this was the reason that we got integration of these functions. We knew that they are derivative of some function. So initially we could not get integration of tan x because we did not know d by dx of which function here. I did not know d by dx of which function is equal to tan x. D by dx of which function is equal to tan x. If I knew this, then I would have written this implies integration of tan x dx is equal to this plus c. So we could not get integration of these all. I have explained you the reason for it, so that now when we will get it, you will understand it much better. So in short, you can say that we were not well equipped. We were not well equipped for writing integration of these. Now, after having these results, these corollaries, which I wrote today for you, we have become well equipped. So using this, we'll be able to write the integration of these all. So let's study. Let's begin. So I begin with the first one is integration of tan x. Here I write right integration of tan x, cot x, sec x and cosec x with respect to x. So the first one is tan x. I write let I equals to integral tan x dx. So students, I write tan x as sin x upon cos x dx. Tan x I write sin x upon cos x. Then I write, see this is denominator cos x, numerator is sin x. I write numerator is sin x. What I do is I put a negative sign out here. So if I put a negative sign here, I will have to put a negative sign here. Negative, negative, positive. So as such, I have not done anything. But if you are asking, if you are thinking that why we do this, it was only a manipulation. So that I can say, now what I can say students, I can say that I have derivative of denominator in numerator. See, cos x is denominator. What is derivative of denominator? Minus sin x. Okay, so for this whole thing, I can use, for this thing, I can use the result. Which result I can use here? I can use this result here. See, this one I can use. What does it say? It says that if numerator is derivative of denominator, then the integration is log of mod of denominator. So I write here, therefore I equals to minus, this minus will remain as it is, this negative sign will remain as it is. Okay, and what do I have for this? I have here log of mod of cos x plus c. Now you know students, a negative sign is equivalent to -1. You understand? Minus, if I have -5, what is meaning of -5? -5 is -1 into 5. So here I have negative log x. So this I will write as, this as -1 log of mod of cos x plus c. That is equal to, now you know m log n is log of n raised to m. This will become, by using the laws of logarithm, this will become power. So I will have log of cos of x raised to -1 and mod plus c. So this I get here, I will get here I equals to log of 1 upon cos x inside mod plus c. And what is I? I was integral tan x. So integral tan x dx is equal to log of mod of sec x plus c. Log of mod of sec x plus c. So we have got integration of tan x, which is log of mod of sec x plus c. I hope you all have understood this. So let's go for the second one. The second is, I'll write let I equals to integral cot x dx. So I write this as integral cot x, I will write cos of x over sine of x dx. Now here I am getting straightway derivative of sine x is cos x. So derivative of denominator is present in numerator. So integration will be log of denominator. So log of mod of sine x plus c. This is I. What I will do, I will now write what I was. I was integral cot x dx. So cot x dx is, integral cot x dx is log of mod of sine x plus c. This is integral cot x dx. Okay, now I go for the third one. The third is let I equals to integral sec x dx. Now students, unlike the previous two where we wrote tan and cot, when I had to integrate tan, what did I do? I converted tan of x as sin x upon cos x. Okay, I wrote this in sin upon cos form. That is, I converted in sin and cos. Okay, so here also I wrote cot as cos upon sin. I converted this in cos and sin. But unlike these two, don't go for writing this as 1 upon cos. Remember, integration is all about applying results. As you will move ahead, you will find that you are getting more and more results. And as you keep getting results, you become more well equipped for integration. Integration is all about applying results, manipulation. Now see, if I write here 1 upon cos x, say I wrote sec x, I wrote next step as 1 upon cos x. Okay, I just try to do what I did for the previous two, that is writing in sin and cos. But then remember students, there it helped me. In the previous two, it helped me. It is not going to help me here. Writing 1 upon cos, what will I do next? There is nothing I can do next. It is not wrong. Sec x is definitely 1 upon cos. But is it going to get me integration of this? Which result do I apply? No result. Okay. So remember, in integration, you have to apply something which gets you the answer, okay, which gets you the result to be applied. Okay, so here see what I do. I write here integral sec x. I write here sec x multiplied with sec x plus tan x divide by sec x plus tan x. So what have I done here, students? I had sec x. What I did, I multiplied sec x plus tan x with sec x, and I divided by sec x plus tan x, which is allowed because I'm dividing both. This is allowed. Next step, what will happen? This will get in sec x into sec x and sec x into tan x. This will get multiplied inside. So the next step, you will get sec square x plus sec x into tan x divide by sec x plus tan x dx. This will be next step. Sec square x plus sec x tan x upon sec x plus tan x. Okay. Now check. I want you all to check what? I want you all to check the derivative of denominator. What is derivative of sec x plus tan x? Let us check. I write here d by dx of sec x plus tan x. So what will it be? It will be d by dx of sec x. It will be d by dx of sec x plus d by dx of tan x. So d by dx of sec x is sec x tan x, and d by dx of tan x is sec square x. So what you notice? You notice that d by dx of sec x plus tan x is sec x tan x plus sec square x. It is sec x tan x plus sec square x. So is it not the numerator here? I notice that d by dx of sec x plus tan x is sec x tan x plus sec square x. And see here I have the same. I have sec x tan x plus sec square x. So I can say that derivative of denominator is present in numerator. I can say derivative of denominator is present in numerator. And whenever such thing happens, I use the corollary, I use the result. Which one? I will write using integral f dash x upon f of x dx equals to log of mod f of x plus c. Okay, whenever derivative of any integrand that you see, you notice derivative of denominator is present in numerator, then the integration will be log of mod of denominator. So what will I become? I will be equal to, I will be equal to here log of, see, I am applying this result having noticed that in this derivative of denominator is there in numerator, I apply the result. So I will become equal to log of mod of sec x plus tan x plus c, log of mod of sec x plus tan x plus c. So finally you write integral, what was I? I was integral sec x dx. So integral sec x dx is equal to log of mod of sec x plus tan x plus c. This is the final one. I hope you all must have understood. Okay, remember one thing, students, that these video lectures will be helpful for you only when whatever I am writing, whatever you see on the screen, you learn it, you pause that screen after the explanation is over, you pause that screen and you copy that in your notebook. If you are not copying it, if you are not maintaining your own notes, your own records, it is of no use. Practice makes you perfect. Remember that. So when we integrated sec x, we got integration of sec x as log of sec x plus tan x plus c. Integration of sec x is log of sec x plus tan x plus c. This is used most of the times, but at few places we have got another form of integration of sec x dx. And what is that form? You will get that form when you will apply some more steps on what you have got. So let us apply those steps. So the next step I will write here log of sec x plus tan x. I can write log of sec x, I can write 1 upon cos x plus sin x upon cos x plus c. So the next step it will become log of 1 plus sin x upon cos x plus c. Integration of sec x, I have already got log of sec x plus tan x plus c. This is quite widely used, but then there is one more form, so we are working for that another form. So the next I will get log of, now you know students, 1 plus sin x can be written as cos x by 2 plus sin of x by 2 the whole square. And here cos x in the denominator, I can use half angle formula for cos x, which is cos square x by 2 minus sin square x by 2 plus c. So the next step I get, now here the denominator, in the denominator this would get me, this is in the form a square minus b square, so this will get me cos x by 2 minus sin x by 2, cos x by 2 plus sin of x by 2 plus c, and the numerator is cos x by 2 plus sin x by 2 the whole square. So you cancel one of the factor, this cos x by 2 plus sin x by 2 will cancel. So what you have is what you are left with is log of cos x by 2 plus sin x by 2 divide by cos x by 2 minus sin x by 2 plus c. What do I do next? I will get here equal to, log of, I'm writing the next step, log of plus tan x by 2 upon 1 minus tan x by 2. How do I get this step? I divide numerator and denominator by cos x by 2. So numerator, when I divide by cos x by 2, I get here 1 plus tan x by 2, 1 minus tan x by 2. So the next step, I write log of 1. I can write it as tan pi by 4 plus tan x by 2. And here I write 1 minus tan x by 2 it is, which I can write tan pi by 4 into tan x by 2. I can write tan pi by 4 into tan x by 2. So here I get this as log of tan A plus tan B over 1 minus tan A into tan B. So this is log of tan of A plus B, pi by 4 plus x by 2 plus c. This is the another form. What is left hand side, students? What is left hand side? Left hand side is integral sec x dx. So here you have integral sec x dx. So my dear students, there are two forms of integral of sec x. One is here and the other is this. You need to remember both. You need to remember both of these. So the fourth one that we will have is let I equals to integral cosec x dx. So what I do is I write cosec x, and once again I will not write this as 1 upon sin x because that doesn't get me the integration of this. So what I do, I write cosec x and I multiply cosec x minus cot x and I divide by cosec x minus cot x, which is allowed. Now why I do that, you will understand very shortly. So next what happens is we multiply this cosec x inside. This gets me integration of cosec square x minus cosec x into cot x. Cosec square x minus sine as it is and cosec x cot x. Divide by cosec x minus cot x and dx. So here I have, therefore, I equals to cosec square x minus cosec x cot x upon cosec x minus cot x. So next what I do is I differentiate this denominator. Let me find the derivative of cosec x minus cot x. What is derivative of cosec x minus cot x? It is d by dx of cosec x minus d by dx of cot x. D by dx of cosec x is, what is d by dx of cosec x? Minus cosec x into cot x minus d by dx of cot x is minus cosec square x. So this negative negative become positive. So you will get here cosec square x positive, which I write as first step, minus minus plus. So I write cosec square x minus cosec x into cot x. This is d by dx of denominator. This is d by dx of cosec x minus cot x. This is what I get. I got derivative of denominator as cosec square x minus cosec x cot x. And see here, students, don't I have same thing here in the numerator? Yes. So I say that derivative of denominator is present in numerator. I differentiated the denominator, I got the numerator. So this makes me use the corollary. Which one? I write here, using integral f dash x upon f of x dx equals to log of mod of f of x plus c. We get what I will get. I will get I equals to, I'm using this corollary here. Why I'm using it here? You know it, because derivative of denominator is present in numerator. I get I equals to log of mod of cosec x minus cot of x plus c. Okay, so this is integral. So I will write integral cosec x dx is equal to, I was cosec x dx. So I substituted log of mod of cosec x minus cot x plus c. This is the final thing. This is the final thing. Okay, so I will be using this one, but for some cases we have one more form which we can use. So for using that, what I will have to do, I will have to work on this form. Okay, so I will go ahead and I will start working on that. So it will get me the another form. So this is one form, and the other form is, see what I write. I keep working on this. So this is log of cosec x is 1 upon sin x minus cos x. Cot x is cos x upon sin x. I am working for the second form. So log of, I have now 1 minus cos x upon sin x plus c. This is log of 1 minus cos x is 2 sin square x by 2. And what is sin x? Denominator, I will write half angle formula. So 2 sin x by 2 into cos x by 2. Okay. So the next, students, next what you will do is this 1 sin x by 2 cancels and 2 cancels. So we have log of, what do I have? I have log of sin x by 2 upon cos x by 2 left. So I have I equals to, what do I mean by I? By I, what do I mean, students? It is this is I, which is integral cosec x dx. Okay, so the next step I will get integral cosec x dx is equal to log of tan of x by 2 inside mod plus c. How tan x by 2? Log tan x by 2, because I have sin x by 2 left in numerator and cos x by 2 left in denominator. So sin x by 2 upon cos x by 2 is tan x by 2. Okay, so this is the next one. So we have got two different forms for cosec integration of cosec x dx also. Okay, what was the first form? Integration of cosec x dx was log of cosec x minus cot x plus c. And what is the second form? The second form is log of tan x by 2 plus c. So let's have a quick revision, a summary of what we did in this lecture. We started with the discussion on integration by method of substitution. We learned that this theorem will be the main theorem and it has got three corollaries. So we learned those three corollaries, and what were those? Those were these three. Integral f dash x upon f of x dx is log mod of f of x plus c. Integral f dash x upon root f of x dx is 2 root f of x plus c. Integral f of x raised to n into f dash x dx is f of x raised to n plus 1 upon n plus 1 plus c. We did this. Then what we did was we used this particular corollary, this particular result, to get the integration of four more standard trigonometric functions, that is tan of x, cot of x, sec of x, and cosec x, and cosec x, and cosec x. So this is what we did today. So let us write these integration of four standard functions once again at one place. So integration of tan of x dx is equal to log of mod of sec x plus c. Integration of cot x dx. What we got, students? We got log of mod of sin x plus c. Log of mod of sin x plus c we got. Then integration of sec x dx, we got log of mod of sec x plus tan x plus c. There is one more, log of tan of pi by 4 plus x by 2 plus c. These are two integration of sec x. Okay, so if you have a question, sir, when to use which one, don't worry, you will know when you solve the problem. I can say only this much, that this one, this one is used more often than the next one. Okay, but you need to know both. And finally we had done integration of cosec x dx. Integration of cosec x dx is log of mod of cosec x minus cot x plus c and log of mod of tan of x by 2 plus c. Okay, so here one more thing I would like to say, and that is that all these integrals today you did, see, each one of them is starting with log. Each one of them has log. You see this? Each one of them have log. So this is one thing that will help you remember. Integration of tan x, cot x, sec x, cosec x, that is other than integration of sin x and cos x. Okay, these two integrations you already knew, you had done earlier. Okay, integral sin x dx, integration cos x dx you had already done. But today you did these four, and you notice that integration of these four, all of these start with log. All of them start with log. Okay, practice them well and try to remember. If you remember these results, you will be able to solve problems better. Remember, students, integration is all about applying results. In the next lecture, I shall be solving problems using these results. Okay, that's all for now. Thank you.